Lesson 8.2, Linear Equations in Two Variables. An equation in two variables contains two different variables. Solution of an equation in two variables is an ordered pair x, y that produces a true statement when the values of x and y are substituted into the equation. The graph of an equation in two variables is the set of points in a coordinate plane that represents all the solutions of the equation. A linear equation is an equation whose graph is a line. This one, we use the word linear, and linear means line, so you can remember that the graph is going to be a line. Function form is when an equation is solved for y. Usually it looks like this: y equals ax plus b. In example 1, we're going to tell whether 5, -1 is a solution of x minus 3y equals 8. What we are going to do here is we're going to take the equation, we're going to take our x and our y, and we're going to substitute it into the equation. So instead of x, it becomes 5. Instead of y, it's -1. We are checking, this is asking the question, does it equal? We are checking to make sure it equals 8. Let's change the subtraction to adding a negative. 2 negatives make a positive 3. 5 plus 3 equals 8. So it checks. It is a solution. If it did not equal, it would not be a solution. Tell whether the ordered pair is a solution of 2x minus y equals 5. Remember to plug in or substitute the x and y into the equation. Tell me yes or no, is it a solution of the equation? Pause the video, try 1, 2, and 3. For number 1, we substitute in our x and our y. Remember to change subtraction to adding the opposite. This is 0 plus 5, which is 5. So it checks. It is yes. Number 2, 2 times 3 is 6. 6 minus 2 is 4, excuse me. And that is still not 5. We use this symbol with the equal sign and the slash to represent does not equal. It is no. Number 3, substitute in the x and the y. Is it a solution? Let's change the subtraction, adding the opposite. This is -4 plus +9. This is 5. It checks. By the way, sometimes you may see that they ask you the question with this semicolon, and then they'll say x equals, or actually they'll give you the ordered pair. Just be careful because they're asking you what the solution is. They're asking you if it checks. In example 2, we're going to graph y equals -x plus 1. So we're going to make a table of solutions. -2, -1, 0, 1, and 2 were given to us for the x. We're going to plug in the x into the equation. I like to actually make these, and when you do it on your paper, this might be easier if you set it up like this, because then what you could do is you could actually see, and you don't even need to put the y down here. You could put -2 plus 1. That's 2 plus 1, which is 3. Oops, apparently it all comes down. So you can see that I kind of leave myself some workspace to substitute in the number, and so on. So this is 1. You can kind of actually start to see a pattern. So this is -1 plus 1, 0, and so on. List the solution as an ordered pair. If you want to skip this step, you may. Just know that this is your ordered pair. -2, 3, -1, 2. Again, these are your ordered pairs, x first, then y. And then you graph the ordered pairs on a line, on the graph, and then you draw a line through it. This is a linear equation, which means if you're not getting a line, then you messed up somewhere. Again, make sure it graphs a line. In example 3, we're going to talk about graphing horizontal and vertical lines. Y equals -2. This line is going to be a horizontal line. Let me show you how. This is saying that y equals -2. So my x and my y, in my ordered pairs, y is -2, x is 0. So we go nothing left or right, we go down to -2, and then you draw a line through it. Now be careful, you're just not going to make a vertical line because you'll be right on top of the y-axis then. So just be careful that you're doing it kind of intersecting the axis. You can see whereas the x equals 3 line, the graph is a vertical line. Because x, comma y, you have x is 3 now, y is 0. So we're going left, right 3, and then we intersect the x-axis. Again, if you're drawing a line across, on top of the axis, then you're doing it opposite. In example 4, we're going to write an equation in function form. That means we're going to get it so that it's y equals ax plus b. We're going to solve for y. So, two sides to the equation. This is what I want to leave alone, the y. But before I do that, I need to change the subtraction to adding a negative. The reason I do that is because technically there's a -1 in front of the y. So this is what I want to stay in place. I want to move the numbers and the variables that are further away from the y, which is 3x. I want to move the whole term, remember we call this a term, the whole term, over to the other side. I'm trying to get it away from the y. This is a positive 3x, so I can add a negative 3x or subtract. You're trying to clear it. You're left with negative y. Again, might be nice to put the -1y. And you have a negative 3x. Because remember, when you move the 3x, you do it to both sides. Now I'm not done. I have to leave a positive y for function form. So how do you get rid of -1 times y? Divide by -1. I'm actually dividing everything by -1. So -1 divided by -1 is y. That's what I want. -3x divided by -1 is positive 3x. And positive 2 divided by -1 is -2, which you could have adding a -2 or you can have subtracting. Now that it's in function form, we can graph this. You're going to set up a table. If they don't give you a table, you're going to, or the x values, you're going to use 2 negatives, a 0, a 1, and a 2. So if they do not give you the x values, this is what you use. You can see we can make, and I actually like to set it up this way again. I put in, even ignore the y, put in my function form, -1, 0, 1, and 2, 3 times -1 plus -2. I can actually just do this, substitute in first. Again, anytime there's an x, I'm plugging in one of these values. And then solve. -3 plus -2 is -5. 0 plus -2 is -2. 3 plus -2 is +1. 6 plus -2 is 4. Now I graph this, and because it's actually a linear equation, so it should make a line. If you're not getting a line, then you're doing something wrong, whether it's changing it into function form or when you go to substitute the values in. And make sure your line is all the way through the graph. And it should extend. It's going on past what the graph actually shows you. For number 4, graph y equals 4 and x equals -3. Well, y equals 4 is 0, positive 4. X equals -3 is -3, 0. Do you see that I have 2 different points? This is not the same line. These are 2 different lines. Pause the video and graph it over here where you have your graph. So this is the y equals 4, and this is the x equals -3. You can see that y equals 4 is a function because when I make a vertical line, you can see I'm only going through one point. But when x equals -3, it's not a function because it is a vertical line. Number 5, we're going to write it into function form first. So here's the y. This is what we want to leave alone right now. So go to the furthest spot, which is the x, and I would maybe change the subtraction too to adding a negative. Just makes it cleaner. I want to move this positive x to the other side. To do that, I want to make it 0. Subtract x or add a negative. You're left with -2y because that makes 0. This is a 4 minus x. Again, you could make it adding a -1 if you prefer. Then, how do you get rid of -2 times y? Divide by -2. To everything. Remember, you are dividing by all numbers, all coefficients, all constants. That clears. Y equals -2 plus 2 negatives make a positive, and it's actually a half x. This is function form, but now I have to graph it. I set up my 3-column table, -2 plus a half x, and that's going to equal y. They didn't give me any values for x, so I'm going to use -2, -1, 0, 1, and 2. -2 plus 1/2 times -2, and you're going to substitute all of this in. Oops, that's a -2 plus 1/2. There's your -1. And you might want to use a different piece of paper so you have more space, and so on. You're going to end up with, you can see this is the same thing. By the way, it is just that it's a little bit reversed. There's my -2. If I change that to adding a negative, here's my half x. Your graph should look similar to this. Double check your points. If you have any questions about how to change a equation into function form, please ask. That's probably the most important thing you can get out of this lesson.